back to CTN. I'm your host, Robert Van Sluten. So blocks, what are they? Well, it's a C-level syntactic and runtime construct. In other words, there's syntax, which obviously in languages you have syntax, but they have a runtime characteristic to them. And the other key is it's C-level. We're not talking about objects here. They're similar to C functions with the addition of state. In other words, there's special scoping issues with variables. So a block actually has information in it in addition to code, which is above and beyond what functions have. They can be cast as parameters and used by multiple threads. So in other words, you can define a piece of functionality with some information and give it to something else to process. And that other thing could actually be another thread. Now, we haven't talked about concurrency yet. We're going to start doing that. Blocks, they're an Apple extension. And Apple has proposed this extension to C to the Standards Committee, the working group. So what's the syntax? Well, it's a little bizarre. This is the simplest possible block definition you could have because it returns a void and nothing gets passed in. You'll notice the caret syntax. The block name is myBlock. So on the left-hand side, we're declaring a variable. And the block name is myBlock. It doesn't take any parameters. It doesn't return anything. It's defined as just simply executing a log statement, hello world. So this is pretty basic. And you'll note that, well, okay, the log's terminated with a semicolon, but also the definition of the block is terminated with a semicolon. So we define a block on the right-hand side of the statement and a variable to that block on the left-hand side. Now here, this is an example. This is just simply a screenshot. It's not something we're going to actually execute. This is to represent the scoping issue. I have a variable called num. And I've defined a block, returns nothing, takes nothing. This log statement outputs the value of num. So I've defined it, but then I went ahead and I changed the value of num to 4. I started out as 2 and I changed it to 4. And then I executed the block. In other words, I ran the code. myBlock. Looks like a C function call. You notice down in the log output, down on the bottom in the debug area, it outputs 2. So the block takes on the value at the point that the block is defined. Now this is the runtime characteristic. So in other words, there's an internal copy. It copies the data in the block. You can hand the block off to someone else or you can execute it yourself. And it will use that information at the point the block was actually defined. Now, because it's a copy, and it also can't be modified, if you actually try to change the block definition such that you're trying to change the value of num to 6 in this case, you'll actually get an error message that variable is not assignable. So they're read-only variables. Now, there's a way of changing that. You can make it so that if you change your block definition such that you say underscore underscore, there actually is 2 underscores here, the word block, init num equals 2 in that variable definition. That's saying that this variable can actually be modified by a block. So the error message actually goes away. Now, where do these come into play? Well, I mentioned threads. You may have a thread, and like I said, we haven't really discussed concurrency yet, but if you look around the foundation, and the example I want to give right now is arrays. An array does a whole bunch of complicated things, and one of the things you can do is you can sort the array. And you can define a comparator. In other words, depending on what kind of things you have in the array, what the type of objects are, you may want a different type of comparison than a simple greater than, less than. And you can define the comparator by giving the array a block. And there's this thing called NS comparator. Now, what is that? Well, it's defined as a block definition if you go look at its definition. And you see here that it's defining a block. And that block has a return value. Now, what is that return value? Well, that return value is an enum. So if you follow this interface specification and you define a block with this return value and this particular definition, you can define a comparator for the objects in the array, and you can do sorts. That's it for now. I hope that helps. Thanks for watching.